All right, welcome back everybody to the Additive Snack Podcast. I'm your host, Fabian Feld, and today I am thrilled to have Stefanie Brickwede back at the Additive Snack Podcast. If you did not listen to our previous episode, it's been a few years, so we'll also give you a bit of a recap on where the Deutsche Bahn and Mobility Goes Additive started, and how they have both very successfully already implemented additive manufacturing in various facets of the value chains. So we'll talk about digital warehousing, we'll talk about true and real savings that the Deutsche Bahn is bringing in day by day by implementing additive manufacturing, and various other facets all the way into how do we collaborate in different parts of applications and industries across additive manufacturing. So therefore, without any further delay, Stefanie, welcome to Additive Snack. Welcome back.
Thank you so much, Fabian. It's a great pleasure, and thank you for having me.
Okay, so we've known each other for a few years now. We also saw each other in New York at AM Strategies. And it really dawned on me that you guys are making such great progress in additive, and it's actually not getting as much attention maybe in the industry as it should, because it is really a incredible story on how much of a difference it makes for Deutsche Bahn to implement additive manufacturing. So I am curious to talk about where you guys are at. Before we do that, can you tell us a little bit about how additive manufacturing started at the Deutsche Bahn?
Yeah, so in this year, we are celebrating our 10th anniversary for additive manufacturing at the German railway company Deutsche Bahn. And yeah, we started with just 10 parts. And that was already, it feels like yesterday, but in fact, it's 10 years ago. And meanwhile, we've printed more than 150,000 parts with 700 different use cases behind. And what is really interesting, with 12 different technologies. So here you can see that we are always exploring new technologies, materials, and opportunities. And yeah, so in the meantime, we've gained a lot of experience, and we started with the obsolescence perspective. So we wanted to get parts we can't get our hands on anymore, which were not available on the markets. And we often operate trains which are 30, 40, 50 years old. And of course, no one can really predict how many parts do I need from this or that. So, and if you want to reproduce those parts, it might be very expensive. And additive manufacturing is a perfect solution for that. That was our start.
Super interesting. And I think there's many parallels that can be taken to other industries and other players in that space. But I remember you being on stage at AMS and mentioning very specific data points and numbers on how many dollars of savings has the Deutsche Bahn achieved today, but also what's the objective? Where do you see additive manufacturing long term at the railway organization Deutsche Bahn?
So what might be also interesting, when we started 10 years ago, we wanted also to learn from others, to scale much faster. And that was that we were looking for a network, didn't find one, and founded our own one. And that was the start of Mobility Goes Additive. Meanwhile, also Medical Goes Additive. So that's now the leading network for additive manufacturing in Europe. And in that network, we also have not only Deutsche Bahn, we have 5 other different very big railway companies throughout Europe. So when I talk about those rail opportunities, it's not just only about Deutsche Bahn, it's also the others. They have to produce under the same conditions, with the same certification and quality aspects and materials and so on. So this is why we can really say, together in a joint approach, we've figured out how to produce parts and how to identify them, because that's always, of course, the first step. You have to take a look at your inventory and to see what can be produced. And when we started, our problem was that we are not a constructive company. We're just a maintainer. So we don't have the database like someone who produces really trains and infrastructure to decide whether a part is printable or not. And that was when we went to our maintenance workshops, asked our colleagues what are the parts they would really need. And meanwhile, we've developed that a bit further. So only a couple of years later, we started with printing tools and jigs and fixtures. Yeah, usually you would do that at the beginning because those are definitely low-hanging fruit. We did that a bit later, but meanwhile, that's also a very interesting aspect of additive manufacturing in the corporate. And now we've really changed that or developed it to a more strategic approach. In the meantime, our databases have become better. So we now try to do this a bit also top down and to see what are the parts for trains as well as infrastructure. So it's always proof. It's a huge corporate. We're talking about a big company of 200,000 employees. So to find the right guys who can answer your questions is already a challenge, but to find the right parts it's even more. And so we're now developing data logics to analyze our parts. And of course, we also use AI, who does not? But that is also a development just of the recent years and also months. And then we also went a step further and we said, at the moment, we were always talking about obsolescence logic, which means the end of the life cycle. Yeah. And then we thought we might have a better impact if we bring it to the beginning of the life cycle of a train, which means that those guys who do the construction and engineering of parts and trains, if they take additive manufacturing more into account, then we can do by far more. And then we can integrate more parts, functional integration, as well as topology optimization. And that is only possible if you do it at the very beginning when you design things. If you want to replace parts, then you always have to stick to form, fit, function of the original part. Otherwise, you lose the certification, in the worst case, for the whole train. So that is something we don't want to have. And that's now the latest point. But maybe we can come back to the strategy of 2030 in a couple of moments.
We definitely should. But I do want to double click on a few things that you just said, because I think it's really interesting from a strategic perspective for others to understand how you guys approached it from the beginning, right? So you did not approach it from the beginning of the life cycle initially. You approached it from the end of life, and you did a bottom-up approach within the organization. It sounds like you identified individuals in the maintenance teams, educated them to have those boots on the ground identify parts versus telling the boots on the ground which parts are viable. Is that correct?
Yeah, it's absolutely correct. Yeah. And the good thing is if you start such a project with a different approach. So usually if you start a technical project, do a big corporate, you would ask the CTOs, can you send me some people who are trained properly and who have the right hierarchy level? And that is something we didn't do. We just asked into the whole corporate, who is really willing, who is really an enthusiast of additive manufacturing, who wants to be on the team. And that was a total different approach. And this is how we get without hierarchy levels or on eye level in discussions with those guys who really can say what is needed, what parts are needed, what use cases, which components. And those came from procurement, from maintenance sites, from the engineering part. So throughout the whole corporate. And so it was really cool to start with a bottom-up approach because usually you would do it the other way around. As a strategist, what I am, you would usually start from the top and then do analysis and get to the point. But since that wasn't possible, we started the other way around. And now we can match both strategic approaches, and that's really cool.
And I'm guessing there were a lot of surprises in there, huh? Do you remember an application where you said, I would have never thought this made sense, or I would have never chosen this application, but it's totally applicable to additive and gains a lot of value from that technology?
Yeah, I mean, additive manufacturing, some people say it's 30 years old, yeah. But the real hype and all this really spread of different technologies just came in the recent years. So from year to year, we have such a great development, and things are possible which weren't possible just a couple of years ago. So to give you an example, when we went to our maintenance side of local passenger transport in Berlin, the guys told us we need to have the seat of a driver, a big metal part. And we said, forget it. Yeah. That was now maybe 8 years ago. And we said, 40 kilograms, we can't do that. Yeah, it's not possible. And if it was possible, you wouldn't want to pay for it. Just 2 years later, we found the appropriate technologies, maybe not for the seat, but for big metal parts. So we built those, for instance, a box which is used beneath the train to prevent it from getting too much into the curves. So it's for a high-speed train going 350 kilometers per hour. It's a safety critical part. And then we were able to do this in wire arc additive manufacturing. And we did a lot of testing. And that was really like, wow, what can we do? And 1.5 years ago, we were addressed by our cargo colleagues, and they had the problem. They had a standstill of 50 cargo locomotives because a gearing house was missing, and they couldn't get it anymore. And if so, they were told you have huge minimum order quantities, and it will take at least 2 years. And we said, no, that can't be true. Standstill of train, so alarm is going on. And so we figured out how can we help those colleagues to get those locomotives back on track. And we started with sand casting and printing the sand molds, and to have the parts casted in the previously used materials. And so we needed to do a totally different technology in AM. We had to find the right partners. We used our network for that. So we figured out what has to be taken into account. Of course, we needed a total re-engineering. So we sent those parts to Romania. They had them re-engineered. We sent that back and have the sand molds printed. And the whole process of getting the first gearing houses just took us 2 months. So we reduced the lead time from like 1.5, 2 years to 2 months. And that was a huge success also within the corporate, because before they discussed that big problem and challenge already in the board. And we were able to deliver the solution. And this is how we try to figure out what are the solutions which we can bring into the corporate, and to rely also on great partners.
Yeah. And I mean, you started with probably somewhat low critical replacement parts in the beginning, and have worked your way up into safety critical applications. How did you approach the internal acceptance of additive manufacturing for safety critical parts? I can imagine that there was a lot of voices that said, no, 3D printing is a prototyping technology. How did you convince the naysayers?
A big advantage is that the whole technology is so haptic. So we brought the first metal printed parts, and that already opened the eyes and the perspective. And then we printed very soon some real typical parts, and to see and to give the idea that things are really possible, which they'd never thought of. Yeah? And of course, it's a lot of talking, you have to convince people, you have to address people via different channels. So marketing as well as communication played a very big role on that whole way. And so we even established an employees competition. So everyone throughout the whole company could hand in their ideas, and we took a look at them, tested them, and then we had a jury consisting of high-level decision makers in the corporate to decide who's the winner of the year in different categories. So we had an award ceremony, and that already took a lot of attention too. So the whole competition had two goals. One goal was to find cool applications, and the other goal was to bring the idea of additive manufacturing into the company, and to find people who really align with that idea. And what really helps also, especially in the last 2 to 3 years, that so many people now have FDM desktop printers at home. So they already know about the idea, and that they can materialize their ideas with additive manufacturing. Of course, not in the right materials and technologies, but the first step was already taken. So they know what can be done. And that also helps to get more people on board, to find more ideas, and to have a bigger team.
Now, you started this process 10 years ago. How did you measure success along the way? Because that's oftentimes also a critical success criteria, right? In order to be able to continue to run such a program, you need to show success and you need to show impact onto the organization. What type of KPIs and measurements are you guys? So
in the first years, that's really funny, because at the beginning I had a discussion with my former boss, and in the first year he said, "Now we have to define KPIs as a manager." I said, "Okay." Since we didn't know about the effects and the costs that much into detail, he said, "We will measure you in parts, printed." So in the first year, you have to bring 20,000 parts. And I immediately burst into laughter, because I know exactly that the aviation guys, and he came from Airbus before, the aviation guys, it took them years to find the first applications, to certify and so on, qualify them. And he was really reacting like, "Why the hell are you laughing?" Then he asked, "How many parts have you already printed?" And I said, 10. And it was clear to him that between 10 and 20,000, there's a huge gap. In the meantime, that has developed. Of course, it does not play the most important role how many parts we are printing. And we always just counted real spare parts, prototypes, or toolings, not giveaways or anything like that. So that was already meant seriously right from the beginning. But today, of course, the most important thing is, what is the effect in terms of money? So if we do the same effect with 10 parts or 10,000 parts, that's not the big thing. But we now have goals expressed in euros. So in the last years, from 2019 on, we've gained effects with 2-digit million euros. So that has really grown a lot. And to take a look into the future, we also have to talk about a strategy which we call manufacturing on demand, and to provide a digital warehouse. And I can assure you, Fabian, there's really the big potential. And this is now what we are aiming for.
Very interesting. Yeah, it's hard to measure success in the early days.
I think you can still measure it. How we do it is we have different sorts of effects. We have procurement effects, so we don't have to face any minimum order quantities anymore. We can overcome standstill of trains or getting parts by far faster. And of course, that has huge effects. Yeah, if you can drive a train where hundreds of people are sitting inside, of course, that has economical impact. And I just mentioned this digital warehouse logic. If you can reduce your physical warehouse, and our physical warehouse is huge, yeah, then it also has an economic impact. And our physical warehouse is at the moment worth, just for the rolling stock, not talking about infrastructure, 1.8 billion euros a year. And you can also, it's the same amount in dollars, 1.8 billion dollars or euros a year. And throughout the industry, the rail industry, we are quite sure that already today we could print 10% out of it. We don't do it due to several reasons, but we could. And this is what we're aiming now for. And this is what we call the road to 100 million. Yeah, it's a bit less than usually. It would be 180 million euros, but the potential is so big. And this is what we're aiming now for. And we try also to engage the whole rail industry, not just the maintainers and operators, but also those companies who build trains or train components. And that was a strategic approach we started 2 years ago, where we said for the new trains, 10% out of those new trains have to be printable to reduce those warehouse effects. And that was a very good start. And now we are doing that for all trains. We started with the high-speed passenger trains, and now it's the rule for all trains we're trying to procure at the market. And that is not just done by Deutsche Bahn. The Dutch colleagues from the NS, they started with that approach. Yeah? It's a very fast-moving, very agile organization, and Deutsche Bahn is by far bigger. But that is something we adopted, and now this is a new trend throughout Europe in rail.
I think what you guys have done very successfully early on is acknowledge the importance of partnerships, and is to acknowledge the fact that you can't walk that railroad alone, right? I think, and I want to dive into that in a little bit. Right, you're the managing director of Mobility Goes Additive as well, which kind of goes hand in hand with your role as the head of additive at the Deutsche Bahn, the German railway organization. Before we dive into that, though, I do want to understand a little bit better your impact, right? Because you have an ultimate euro goal, but that consists of many facets, of course, right? Lead time reduction can be translated into dollars. Your reduction in working capital by reducing your warehouse can be translated in euros, et cetera, et cetera. Can we double click on all of those? So from a lead time perspective, when do you guys have certain lead time thresholds where you say if a certain lead time is XY months, weeks, then we look at additive, or how do you approach that trigger point?
Yeah, so it's a bit difficult to say because it also depends on the use case. What plays for us a big role is the whole certification process. Before we bring in a part or also replace a part, then we have to fulfill the certification process. And usually that takes the longest time. So the printing process itself isn't the most difficult part. It's more the time which is needed to do this whole certification. And of course, therefore, you need to fulfill a lot of testing. You also need, of course, standards for that. And that is, by the way, also something we developed in cooperation with standardization bodies like the German Institute of Norming. And we've created a norm which is now well known. It's the 52920 to see that are certain production sites, also printing service bureaus, capable of printing critical parts. And so you can see over the long period of 10 years, we even created the missing standards, which are not just applicable for rail, they are general ones. And so that was also crucial to us. So if you ask what takes the longest time, it's more the certification, and the more norms and standards we have, the easier it gets. So this is also one of our focus points at the moment. And of course, for us, it's great if it's not just a German standard. It needs at least to be a European one, even better an ISO or ASTM norm, so that we can integrate the whole AM industry. And we strongly believe, I'm a professional network, we strongly believe in joint approaches throughout different industries with people who all have the same aim, and to help each other, and because then it becomes faster, cheaper for everybody. Yeah. So, yeah. And if you ask for big metal parts, maybe if it takes more than half a year, maybe that's a bit tricky. But it also depends. If we are suffering a standstill of trains, a potential one, then the interest, of course, is big.
Yeah, it seems like it's quite a complex formula. If it's worth the investment of going through the qualification and certification of a part. Last question on the warehousing before I want to go into how do you manage the digital building up a digital warehouse, right? I can imagine that especially in the end of life applications, drawings aren't available. They're in 2D on paper with handwritten notes on them. I can imagine that sometimes the ownership of the application sits with a supplier. How do you manage all of that and then collect all that data, I'm guessing, on some sort of platform that is then available to the procurement team? That seems very complex. It seems like a simple idea, but the execution seems very complex. How have you guys managed to find a way through that complexity?
Yeah, that's a very good question, because of course you need a certain IT, otherwise you can't scale. So we also screened the market about that, and we tried out different software companies, products, and so on. And we chose different ones also over the years. So for instance, for our competition, our employee competition I already mentioned, we used one to identify parts and to hand them in as an idea to our team. So, and this automation process is still going on. So we've integrated some aspects, but we also built an own environment, to be honest, because that has to be usable also within the existing landscape of software we use in the corporate at the moment. And we started with Excel lists, of course. That has a very short end because you can't work with that anymore. But this is how we identified the right ones. We tried them out. We did this also in the corporate, and we started a lot, ultimately with using printing service bureaus, and that also has changed in the meantime. So now we also have 2 own production sites, which we use in the corporate. That is one, they do jigs and fixtures, and another one is responsible for printing flame retardant materials, which fulfill the very high norms in rail. And but for metal parts, for different specific materials, for cell molds, we still use suppliers in AM, and those have to be integrated in that logic as well. So, but we're constantly working on that. So we are working on this digitization, optimization process, because otherwise we will fail to produce that many parts we will need for our 100 million road.
Yeah, the railroad to 100 million. Okay, suppliers obviously play a huge role. If I understand correctly, you mainly rely on suppliers, especially for except for a few applications that you deem either critical or where you have no supply chain out there. I think for certain materials. How do you select suppliers, and then how do you qualify suppliers for the organization?
Yeah, so we constantly screen suppliers, and we are also active being on the main events. For instance, just 2 weeks ago or last week, the AM Forum in Berlin. But we are also looking worldwide, also at the AMS we've already mentioned, or AMAC. But usually that is the main task of one of my colleagues. Yeah, so he's our technology scout, trying to find the perfect material, machine solutions, printing service bureaus, and that is an ongoing process. Yeah, we still have to do that, and the more we talk about additive manufacturing, the more use cases we identify, up to a concrete printed station bench. Yeah, that of course is a totally different world in its own. We have to be very, active also in talks, and mainly, of course, we use our MGA network for that, because in the MGA network we have now 150 member companies. And they cover the whole supply chain, from machining producers, material providers, software companies, consultancies, also a lot of R&D institutes and universities, because sometimes we try to work on totally different new subjects, like, for instance, a powder which can be used for this flame retardant parts. So far, we just could use Autumn 9085. But the whole rail industry was longing for a powder which can be used for that. And this is something we shouted into the network, and two members, Siemens and a material provider from Hamburg, Lehmann and Voss, they created a new material which is now being certified and qualified. Yeah. And that fulfills the very high norms. And that is very typical for how that network also works. We try to bridge the gap between the user's perspective, and that's very user dedicated, the whole network, and the AM industry, because they already know what they can deliver and they have great technologies and machines. But they often need to know what exactly is the user longing for. What kind of use cases, what kind of quality levels are they looking for? Technical data. And we try to create also the standards to bridge that, like, for instance, also technical data sheets, to have a standard on that. So those companies are more comparable, and that's, of course, very urgently needed by potential users who maybe are just about to enter additive manufacturing.
Yeah, like I mentioned earlier, I think it's a very interesting approach how you guys have created a network with various other closely related, but sometimes even a bit further related industries. Tell us a bit more about Mobility Goes Additive. How did the founding process start? Who were the first members, and how has it grown over the time?
Yeah, so we started with 9 founding members 9 years ago. And at the moment we are nearly 150. In a European setting, but we also have some companies from the US, from Asia, who are really interested in exploring additive manufacturing. And we do not just cover rail. In the network, we cover aviation, automotive, aerospace, construction printing. I already mentioned concrete. So just lately, we founded working groups on defense. That's playing a bigger and bigger role, especially since we in Europe are very much affected of the Russian invasion in Ukraine. Yeah, so additive manufacturing also got a big hype in those critical situations. And last week, we founded a new working group on public urban transport. They are very similar to the rail guys, but of course a bit, in details, a bit more specific. And we founded a working group on lifestyle. Lifestyle has definitely nothing to do anymore with this very industrial, techie logic. So it's about the beautiful things in life, about fashion, jewelry, as well as interior design, lamps, decorative things. So that was really a very cool energy in the room because that was full of designers. And in AM, we often talk about design for additive, which sometimes, to be honest, is an excuse that additive manufacturing is a bit more expensive than other technologies. But those designers, they don't design for additive. They do their designs and use additive to do this. It's a bit different as an approach. So, and that was really, really cool. And of course, in the network, we also cover medical, and medical is a huge sector on its own. So there we are also working, like in the mobility field, in working groups. And those working groups try to overcome the hurdles which exist. So to think about certification also in the medical field, how to fulfill the levels of the medical device regulations to bring parts into the body of patients, until bioprinting, which is the next big thing in medical printing. And we even designed great events for that, like the European Hub Forum for Additive Manufacturing, taking place in June in Basel.
What really dawns on me is that it seems like the mobility goes at the start as a mobility cluster, but it really expanded into various other industries, and I think with good reasons, right? Because oftentimes the challenges are the same. It's a manufacturing process where the material gets created as we go, right? Where typically we have stock material that is already designed to certain specifications, and industries struggle with that. It also is true that various contract manufacturers or supply chain partners serve multiple industry verticals, right? Such as aviation and rail, for example. So how do these industries collaborate with each other, and how do they really learn from each other to lift both up? How do you manage that?
Yeah, so on a very global level, they all have the same challenges. They have the certification aspect, they have the material things. They also need to identify the printable parts where it really makes sense to use additive manufacturing for. The education is very similar. So to find more people who are really capable of working with additive manufacturing and designing, constructing for that. Then ecological sustainability plays a big role throughout all those industries, especially in Europe, because that's a very big task. You also have to prove where do your parts come from, which materials are used, which kind of labor is used to prevent children labor being used, and so on and so on. And those are all obstacles which need to be solved. And of course, if you do that jointly, then it's by far easier. So also talking about how big is the energy consumption in a certain technology, for instance. Can we recycle certain materials? Yeah. And in the AM industry, we often talk about what can be done with used powders. Can it just be used for the next printing job or not? Is that really recycling of material? So if you would ask someone on the streets, they would say, yeah, but that's your biggest advantage, that you just use the material for the print job, which is definitely needed for the part. So aren't we mixing up things? But those are things we have to discuss and find solutions, and also address all those big advantages towards decision makers and companies to get more people interested in AM, as well also policymakers, and politicians, to ask for new funding programs, for instance. And that is going on after the elections in Germany as well as Europe, to get more focus on this perfect technology, and not only focus, but also help concerning education, concerning funding programs, concerning all those aspects which can just be regulated by maybe also legislative institutions.
Yeah, very interesting point. You guys are somewhat of a role model on how additive manufacturing has made your supply chains more resilient and more adaptive to various types of changes, right? I mean, throughout your 10 years, you've probably been impacted by the Russia-Ukraine conflict. You've probably been impacted by the Red Sea attacks of the Houthis. You've probably been impacted by even natural disasters. Do you see various governments realizing that additive is not the solution to all, but is a piece of the puzzle to help us create more resilient, more efficient, more sustainable supply chain where we actually manufacture parts where they are needed and when they are needed?
Definitely. So you've mentioned so many big advantages already of the technology. I would love to add one more, and that is also material. If you're talking about raw materials, those are getting more and more scarce. And if you want to have a reduction of materials, if you want to do lightweight designs, if you want to have less energy consumption and less carbon footprints, then you need to have a technology which needs less material. And to be honest, if you take a closer look at where do our raw materials come from, usually that are not democratically ruled countries. So if you want to become independent from also those countries, you need to recycle materials and to use less material in general. And the only technology which can do that is additive manufacturing. So this is a very, very important aspect, which is not always on the radar of policymakers, and also not only also companies. And this is something we also want to bring on the radar, on the agenda, to support people who are using additive manufacturing also from that point of view.
Really good point. And even the ability to create new material compositions, whether it's alloys, whether it's also different polymers and composites, where additive is starting to, I think, gain traction, right? For the longest time, we've had a very limited number of materials in the industry, and we're starting to see very fast adoption of either legacy materials that weren't available in additive or completely new compositions where additive manufacturing can outperform certain types of conventional materials. How do you guys approach the material development? You mentioned that one material that you've developed within the mobility goes additive ecosystem. Are there other material projects you're working on or looking into?
So, for instance, a couple of months ago, a member company asked us, how about copper? I would love to know exactly what can be done with copper. So we shouted into the network and asked for companies already, and also R&D institutes who are already dealing with copper printing. And within just 14 days, we had a workshop with 16 companies talking about technologies, material specifications, use cases all around copper. And that's one of the big advantages of such a network. So you can learn much faster. Just think about, you would use consultants that would take maybe longer and would also be more expensive. And what we also do is we also look into high performance, not only polymers, but also aluminum alloys. Those are really crucial, for instance, for train car bodies, if you want to repair them. So repair solutions will play a by far bigger role in the future. And especially if you have very complex parts, and those colleagues from Siemens in the energy part, they've shown already many years ago in Fingsborn in Sweden what they can do with the repairing of very complex energy parts. And this is now a logic which is gaining from industry to industry, and what we can also enhance jointly. And therefore, you just mentioned that, therefore also need not only the right material, but also the combination maybe of different alloys, because if you just cut parts away from an existing part and you want to rebuild that with using additive manufacturing, of course, you also have to do a lot of testing that those materials really fit and and are also resistant to the whatever used ecosystem.
Yeah, material data is key to a new material taken up. Do you see that oftentimes being shared within the Mobility Goes Additive network, or do you see that being treated proprietary in certain cases?
Yeah, good question. Yeah, so from a user's perspective, it does not make sense to just keep it as an own treasure trophy. It's by far better to spread the word about the materials and the specifications of your materials which are used. So this is something we are working on, coming from the user's perspective, to work on a standard for technical data sheets, so that different materials and providers can be compared, and so that you can pick those materials and with their specifications which you would need for your own part, use case, whatsoever. And this is sometimes where we have to convince the suppliers, and additive manufacturing is fantastic technology, but in some sectors are still covering just a niche. But people in the AM ecosystem always think they have the biggest solution, and this is why everyone has to change his or her processes to adopt. Yeah, that will never happen. So if you have to be corporate, you need the very easy integration of those technologies and materials. And therefore, we need those standards. And this is why I always say standard setting is really, really sexy, because then, and only then, we can enhance the number of parts significantly.
Yeah, it's interesting. Just a few years ago, the sexy topic in additive manufacturing was cool topology optimized parts that looked like they came from an alien ship. Today, the sexy topic is, to me, boring parts, meaning supply chain applications that look exactly like a conventional part, but create value just by having a supply chain advantage, and standards that can create more of these boring parts and the implementation of them. And that, to me, is a sign of maturity of the additive manufacturing industry, that we're actually focusing on these boring topics that have huge impact.
You're totally right, Fabian. And when I started with AM, I was always in discussion, also on panel discussions on stage. I was always addressed by AM dinosaurs, and they always said, you have to design for additive. And I said, I don't have to do anything. I need parts. I have special use cases in my mind, and I need solutions for that. And whether I change the design or not, that is my decision as a representative of a typical use case company. And that has meanwhile changed a bit. And I'm really grateful for that, because before I often had the feeling that the AM sector wanted to teach and to convince the potential users, and it has to be the other way around. The AM technology has to adapt to the users. and not the users to the AM technology. Yeah, and now over the last, I would say, 12 to 14 months, but only, the industry, at least some of the guys in the industry, understood. Yeah, and to step into the shoes of the users, that is so, so important. And if they would really do this, they would sell more machines, more materials, more parts. But there's still a little way to go.
There's still a little way to go, but we're inching our way closer and closer to that picture. It's interesting that you say that. So last week we had Punkel Racing on, and Stefan, who was our guest, said he always compares additive with electromobility. And first I was like, is that a good comparison? But actually, now that you say that, it is, right? The more in the electric mobility space you create a similar experience to conventional automotives, the more adoption you will see, right? The faster the charging time and the faster charging is closer to filling up my tank of gas, the more adoption you will see. And it's the same with additive. The more and easier we can integrate into conventional supply chains, into conventional manufacturing houses, standards and requirements, the faster the adoption will be.
I mean, it's always a big discussion if you want to be disruptive, which is also one of those buzzwords, yeah. And AM certainly enhances the opportunity of disruption. But disruption is not needed everywhere and by everybody. So we need both. We need the disruptive logic, and we also need the, let's call it, adaptive logic. Yeah, so that you can learn and get a better feeling. Because if you're addressing such conservative sectors and all those sectors with a very high safety level, like aviation, rail, defense, energy, they are very conservative, and you have to give them also a chance to learn what is possible. And then if you have a certain education level, then you can also come in with disruptive use cases, disruptive strategies, and then it will be possible to enhance the parts.
Totally agree. Disruption is needed in certain cases, but in other cases, all we need to do is be a tool in the tool belt of manufacturers. Now, I have two more questions for you, Stefanie. Question number one is, like I mentioned, you wear two hats at all times in your working life. The hat of head of additive at the Deutsche Bahn, the German railway organization. I always need to translate that because I do realize that not everybody knows what that is. And the managing director of Mobility Additive. How do you manage these two roles? How often do they merge? Do you treat them separately? What does that look like?
Usually they fit perfectly. Yeah, because as a big corporate, and I already mentioned some examples, we try to use the technology and also the network to help us to find solutions for daily challenges. And on the other side, being in a big corporate, and I mean, MGA can be compared to a startup, very agile, small, fast. And so for me, it's always a big fun, because if I need the cool, very elaborated processes, I take the examples from Deutsche Bahn. If I want to be very agile and fast and learn with others, then I'm more on the side of MGA. So that's the big fun part.
Yeah, it seems like you have a lot of fun in your role and having a great impact, not only on the railway industry, but on various other industries together. Now, what's next? What's next for the Deutsche Bahn? What's next for Mobility Additive? What are your growth plans and where do you want to end up in the next few years?
Yeah, so at Deutsche Bahn, we are now heading for that huge potential of 100 million, and therefore we need also the supplier industry. And I not only mean the AM suppliers, but also the rail suppliers. And I've already mentioned that the whole rail industry is also a very conservative one. So this is something we're trying to put now on the agenda to work jointly also with the rail industry on new logics and parts and topology optimized things. So this will be the big thing of the years until 2030. So until 2030, we want to have this logic fulfilled. At MGA, we are constantly growing, and I already spoke about different sectors and just recently lifestyle. At the moment, defense plays that big role, and I'm absolutely sure that we can spread the word by far better if we also have some cool use cases to convince not only companies but also policy and politicians in general to help us with the technology. So there is so much to do, and I'm absolutely sure that, for instance, food printing might be interesting, focusing on energy might be interesting, maritime. There are so many sectors which are not in detail explored yet, but from year to year, we will integrate more. And I always say the sky is the limit, and even that is no limit because we do aerospace already. So we want to have them all in the network, and we want to see what can be done with this brilliant technology.
Really good points. Not even the solar system is the limits anymore. We have parts on Mars. So yeah, super curious to see how that evolves over the next few years. Stefanie, I want to say thank you for a few things. First of all, of course, for being here today and sharing your wealth of knowledge with all of us. I'm very certain that many people can learn a lot from how you, the Deutsche Bahn, and Mobility Goes Additive is approaching additive, from the strategies and also from the lessons learned and the failures that you guys have gone through. And of course, then therefore, also for being such an influential person in the additive manufacturing space. I think every time you are at a conference speaking, people take a lot of notes, and you bring the industry together. You cross the bridge between industries, which I think is hugely crucial for us all to be successful. So thank you for everything you do for additive and for being here today.
Thank you so much, and please spread the word. Together we will boost AM.
Together, we will push AM 100%. And to you out there, our guests, thanks for tuning into today's episode. Please feel free to also comment in YouTube if you have questions for Stefanie or myself. We'll make sure to answer those. If you like this episode, share it with a friend, a colleague, or somebody who should learn more about additive, whether if that's personal or, of course, job related. This was the Additive Snack Podcast, and I will see you next time.